All right, today we want to start talking about zero and negative exponents in the terms of an exponential function. Yesterday we talked about how to evaluate zero and negative exponents. Now what we're going to do is we're going to look at exponential functions and eventually get to graphing these. First thing we want to understand is what is an exponential function? Well, first of all, it's a function. And it has the form y is equal to a times b to the x. So it's called an exponential function because we have an exponent as our variable. A couple things about this. We're going to have b greater than 0. Obviously, this would make sense. We're not going to have a negative number raised to an exponent. That'll be taken care of with the a value. The other thing is b cannot equal 1. If b equals 1, you end up just graphing a line because 1 multiplied by itself, however many times you want to try, is still going to be 1. So you just end up with whatever that a value is. Now, we want to start graphing these. If we're going to do this, and this is where we always start when we don't know how to graph something, is we're going to make our XY chart. You guys may call them in or out tables. But what we're going to do is we're going to pick some values. We're going to plug them in for x, see what our y value is. So if we pick -2, -1, 0, 1, 2, and 3. We take these values, we plug them into our equation up here. So if we plug in -2, we get 2 to the -2, which is, if you guys remember from yesterday, 1 over 2 squared, or 1/4. So when x is -2, our y value is 1/4. We do this again with -1. We take 2 to the -1, and we get 1 over 2, or 1/2. We keep going, we get 0. So we get 2 to the 0, which is 1, if you remember that from yesterday. And we get 2 to the first, which is 2, 2 to the second, which is 4, and 2 to the third, which is 8. So now we've got a whole bunch of x values, we've got a whole bunch of y values. So let's try and graph these. We go -2, 1/4. Now obviously your graphs are not going to be perfect. I don't expect them to be. Just give me your best shot. I'm not going to measure whether you went a quarter of the way up or a sixth of the way up. But I will look to see that it's less than 1 and probably less than a half. If I give you a graph, you have less freedom than you will like on your homework. When I have you graph those, you will need to, you can scale those however you want so that you can get nice points. If I give you something like this, just do your best. Just do your best to approximate where they are. Obviously, my 1/4, my 1/2 here look very similar since I have -1, 1/2. At 0, I have a value of 1. At 1, I have a value of 2. And at 2, I have a value of 4, 3, and I'm all the way up to 8. So this is what an exponential curve is going to look like as you keep getting smaller and smaller x values, as in they get more and more negative. You get closer and closer to 0. As you get bigger and bigger in the positive direction, you're going to get bigger and bigger y values. If I were to give you some number in front of this, say I change the equation to y equals 3 times 2 to the x. You would handle this first, this 2 to the x first, then multiply by 3. Okay, so it doesn't matter what numbers I give you. You're going to go through this process of making your XY table. Just make sure you do your exponents first, which should make sense from our order of operations, and then multiply by whatever number is out front. In the case of our example here, that number out front is just 1. So, a professional basketball player's first year in the NBA was 1998. Suppose it were estimated that from 1998 to 2010, his average points per game could be modeled by the equation P equals 18.5 times 1.038 to the T, where T equaling 0 is going to be the year 2000. First thing we want to do is we need to estimate the player's average points per game in 1998. The first thing we want to look at is, and I'm going to do everything for part A in blue, how many years after 2000 is 1998? Well, it's 2 years before. So our T value is going to have to be -2. Now that I know that my T value is -2, I can just plug into our equation P equals 18.5 times 1.038 to the -2. And from here, you can either use a calculator or work it out by hand. But either way, you're going to get that P is equal to 17.17 from your calculator. A word on using your calculator: if you're going to type this in, put in parentheses around your -2 when you raise that to the -2nd power. It'll make things go a lot smoother for you. Now that we've got the first part taken care of, we want to estimate his average points per game in the year 2000. 2000 is 0 years after 2000, which we are given. So our T value is going to be 0. We plug into our formula. P is equal to 18.5 times 1.038 to the 0, which this is still going to equal 1 because it's raised to the 0 power. We're just left with P is equal to 18.5. So these are just estimates, given that we have this function. So this is what we would estimate to have happen in the 2 years that we were asked to solve for. That's all I have for you today. If you have any questions, please let me know. Shoot me an email. We will check this homework when I come back. If you can't find it, it's posted on my website under lesson plans, or it's posted in the back of the classroom. If you have questions, shoot me an email, let me know, and I will be glad to help you.